Now let's discuss the constant volume calorimeter. Now the constant volume calorimeter, from its name, the volume will not change. However, because it's made out of hard materials, the pressure will be able to change, but the volume will not change. So now, as you can see, there's a major difference between a constant pressure calorimeter and a constant volume calorimeter in terms of structure or shape. Now, as always, we have a stirrer, we have a thermometer, we have the hardware that includes the outside insulation box or structure and the inside chamber where the reaction will happen. This calorimeter can be filled with water that will help us to measure the change on the temperature. Now, in the inside chamber, this is where the reaction happens. So when we mix the reactants will react. Usually this is a violent reaction, and that's why it's called bomb calorimeter. So there will be kind of a small explosion inside, and there will be a heat transfer from the reaction to the outside. Now, when the heat is transferred from the reaction to the outside, we can measure the change on the temperature of the water and the calorimeter using the thermometer. Now, in a similar way, we can say that the heat released by the reaction is equal to the heat absorbed by the calorimeter. So not only water, it's going to be water and the hardware. And in this case, the heat absorbed by the calorimeter is equal to the heat capacity of the calorimeter multiplied by the change on the temperature. Now, for a bomb calorimeter, we said it's going to be a sealed container, and therefore the volume doesn't change, and delta V is equal to 0. If delta V is equal to 0, work in this case will also be equal to 0. Now, we know that delta E is equal to heat plus work. Work is equal to 0, and in this case, delta E will be equal to heat at constant volume. So that's why we have the subscript V here. Now, as I have mentioned before, now we have a heat capacity for the calorimeter itself. And therefore, the energy released by the reaction is equal to the energy absorbed by the container, which is equal to the heat capacity of the calorimeter multiplied by the change on the temperature. Now, how can we find the heat capacity of the calorimeter? Now, we have said that a bomb calorimeter, it's constituted from two parts, the hardware and the water. So the hardware, such as the metal made from, and the water that we fill in the calorimeter. Now, the hardware has a heat capacity, that's going to be C hardware, and water has also heat capacity. Now, the heat capacity of water can be calculated from the specific heat capacity of water that we have explained earlier, 4.18 joule per degree Celsius per gram, and multiplied by the mass of water that we know it because we filled the calorimeter with water. So in this case, to calculate the heat released by the reaction, we can use the heat capacity of the calorimeter. The heat capacity of the calorimeter is equal to the sum of the heat capacity of water plus heat capacity of the hardware. Heat capacity of water can be calculated from specific heat capacity of water and the mass of water, and therefore we can say that the heat is equal to the specific heat capacity of water multiplied by the mass of water multiplied by delta T plus the heat capacity of the hardware multiplied by delta T. Usually in exercises or problems like this, you will have all the terms except one, and you will be asked to find the unknown value. The main difference between constant volume calorimeter or a constant pressure calorimeter is that the constant volume calorimeter has a heat capacity. I hope this video was helpful to you, so please like, share and subscribe, and I'll see you next time.